ቀጥታ ወደ ሶሉሽናችን ስንሄድ r ምንድነው ብለናል? using ratio test it's the limit of n plus 1 over n. ስለዚህ r is equal to the limit of n plus 1 over n as n approaches to infinity. ይሄ ማለት the limit of 4 the power of n plus 1 over n plus 1 factorial divided by ራሱ which is 4 the power of n over n factorial as n approaches to infinity. ስለዚህ ይሄንን further simplify ስናደርገው ይሄኛው ይመጣል። ስለዚህ ከዚህ n factorial by n factorial 4 the power of n by 4 the power of n cancel out ያደርጋል። ስለዚህ ምን ይቀረናል? the limit of 4 over n plus 1 as n approaches to infinity which is equal to 0. ስለዚህ ቅድም በዘረዘርኩት property if r is between 0 and 1 if r is equal to 0 the series converges ማለት ነው። ስለዚህ using ratio test the series from n is equal to 0 to infinity of 4 the power of n over n factorial converges. በመቀጠል the root test እናያለን። ስለዚህ let's say we have a positive series the summation of an and if r is equal to the limit of the nth root of an as n approaches to infinity then we have three cases as similar to the ratio test. if r is between 0 and 1 r ከ0 ጋር እኩል ሊሆንም ላይሆንም ይችላል። ስለዚህ እዚህ ኮንዲሽን ላይ ሰሜሽናችን ኮንቨርጅ ያደርጋል። if r is greater than 1 ሰሜሽናችን ዳይቨርጅ ያደርጋል and if r is equal to 1 ቴስታችን ፌል ያደርጋል። ማለትም ሌላ ቴስት ነው መጠቀም ያለብን ማለት ነው። ስለዚህ በዚህ መሰረት ይሄንን ኤግዛምፕል እናያለን። ስለዚህ ሶሉሽን r ምንድነው ብለናል? the limit of the nth root of n as n approaches to infinity ነው ብለናል። ስለዚህ the nth root of የዚህ ሲኩዌንስ ምን ይመጣል? the limit of 2n plus 5 ያው n በ1 over n ስለሚጠፋ over 6n plus 7 as n approaches to infinity. ስለዚህ በሊሚት ህግ መሰረት ይሄኛው 2 over 6 ይመጣል which is equal to 1 over 3. this is between 0 and 1. ስለዚህ ምንድነው ይሄ ኢምፕላይ የሚያደርገው? summation of an which is 2n plus 5 over 6n plus 7 the power of n from n is equal to 1 up to infinity converges. Now we're going to look at how to evaluate some special limits. ስለዚህ ይሄን የምናደርገው ratio test እና root test በመጠቀም ነው። if the limit of n plus 1 over an or if the limit of the nth root of an is less than 1 then the limit of a given sequence an as n approaches to infinity is 0. ስለዚህ በዚህ መሰረት ይሄንን ኤግዛምፕል እናያለን። ስለዚህ እዚህ ጋር ሬሾ ቴስት መጠቀም እንችላለን። ሬሾ ቴስት የምንጠቀመው the limit of n plus 1 over an less than 1 መሆኑን ነው as n approaches to infinity። ስለዚህ the limit of 2 the power of n plus 1 over n plus 1 factorial divided by an which is the sequence itself as n approaches to infinity. this is the same as saying n simplify ስናደርገው n factorial by n factorial to the power of n but to the power of n. ስለዚህ the limit of 2 over n plus 1 as n approaches to infinity is 0 and 0 is obviously less than 1. ስለዚህ ከዚህ ምን ዲዱስ ማድረግ እንችላለን? በቴዎሪሙ መሰረት the limit of 2 the power of n which is an over n factorial as n approaches to infinity is equal to 0. በመቀጠል comparison test እናያለን። የመጀመሪያው comparison test is direct comparison test። ግን መጀመሪያ ዲፋይን ስናደርገው ሲሪዛችን በጣም ኮምፕሊኬትድ ተርሞች ካሉት ሌላ ሲምፕለር ተመሳሳይ የሆነ ሲምፕለር የሆነ ተርም ያለው ሲሪስ በመፈለግ ከዛኛው ጋር ኮምፔር በማድረግ ኮንቨርጀንሱን ዲተርማይን እናደርጋለን። ስለዚህ ዳይሬክት ኮምፓሪዝን ቴስት ላይ if we have a larger series summation of bn as compared to summation of an which is given, summation of bn converge የሚያደርግ ከሆነ summation of an also converges. Similarly ደግሞ if summation of an diverges then summation of bn diverges. ስለዚህ በዚህ መሰረት አንድ ኤግዛምፕል እንዲ ስለዚህ እዚህ ጋር ምንድነው ትሪኩ bnን የምንመርጥበት መንገድ ነው። ስለዚህ እዚህ ጋር ኮንቪኒየንት የሚሆን bn ነው መምረጥ ያለብን ማለት ነው። ስለዚህ እዚህ ጋር let bn is equal to 2 over 7 to the power of n over 7 the power of n. We know that bn is greater than the given sequence an ማለትም to the power of n over n square plus 7 the power of n is less than to the power of n over 7 the power of n. ስለዚህ ይሄንን ከዚህ ጋር ኮምፔር በማድረግ የዚህኛውን ኮንቨርጀንስ ዲተርማይን ማድረግ እንችላለን ማለት ነው። ስለዚህ ይሄ ግን እንደምናውቀው ሰሜሽን ኦፍ to the power of n over 7 the power of n ማለት 2 over 7 the power of n ማለት ነው from n is equal to 1 up to infinity. We know that this is a geometric series in which the common ratio is the absolute value of the common ratio is less than 1 ማለትም the common ratio is between -1 and 1. ስለዚህ በጂኦሜትሪክ ሲሪስ ሩል መሰረት ይሄኛው ሲሪስ ኮንቨርጅ ያደርጋል። ስለዚህ summation of 2 over 7 the power of n from n is equal to 1 up to infinity converges by geometric series rule. ስለዚህ የኮንቨርጅ ካረገ ምን ብለን ዲዱስ ማድረግ እንችላለን? summation of an ወይም summation of 2 the power of n over n square plus 7 the power of n from n is equal to 1 up to infinity converges. ከዛ ደግሞ ሊሚት ኮምፓሪዝን ቴስት አለ። if we have two series summation of an and summation of bn and let L be the limit of an over bn as n approaches to infinity, ሁለት ኬዞች አሉን። if the limit is greater than or equal to 0 እና summation of bn converge የሚያደርግ ከሆነ summation of an definitely converge ያደርጋል ማለት ነው። ግን if L is greater than 0 strictly greater than 0 or L approaches to infinity ከዛ ደግሞ summation of bn diverge የሚያደርግ ከሆነ summation of an diverge ያደርጋል ማለት ነው። ስለዚህ በዚህ መሰረት አንድ ኤግዛምፕል እናያለን። ስለዚህ እዚህ ጋር ትሪኩ ምንድነው? ለbn የምንሰጠው ቫልዩ ነው። ሊሚታችን ኢቫሉዌት ስናደርግ ሲምፕል እና ቀላልና ኮንስታንት ቁጥር እንዲመጣ አድርገን bnን ቹዝ ማድረግ አለብን። ስለዚህ in this case let bn is equal to 1 over n square. ስለዚህ በዚህ መሰረት L ማለት the limit of an over bn as n approaches to infinity ነው, which is equal to the limit of sine of 1 over n square over 1 over n square as n approaches to infinity. ነገር ግን 1 over n square 1 over n square as n approaches to infinity ማለት ይሄንን ተርም ሙሉውን 1 over n square let's say m ብንለው m ብንለው as n approaches to infinity ይሄ ሙሉ ምን ማለት ነው? approaches to 0 ማለትም m approaches to 0። ስለዚህ 1 over n square ን m ብንለው let 1 over n square equal to m. This implies that L is equal to the limit of sine of m over m as m approaches to 0 ምክንያቱም as n approaches to infinity ማለት m approaches to 0 ነው ብለናል እዚህ ጋር። ስለዚህ ደግሞ ይሄ እንደምናውቀው it's 1. This is definitely greater than or greater than 0. ስለዚህ ምንድነው የsummation of bn convergenceን ቼክ እናደርጋለን። summation of bn ማለት it's 1 over n square from p series 1 over n the power of p form p is greater than 1 ማለትም summation of bn converge ያደርጋል ማለት ነው። ስለዚህ summation of bn converge የሚያደርግ ከሆነ by limit comparison test summation of an converge ያደርጋል ማለት ነው።